This is the last video for semester 2 of geometry, and it's kind of an afterthought video, which is why there are no notes for it in your note packet. But at the end of your note packet at the very bottom, it said you're now ready for test 6. And there's some extra space there. You can use that or use a blank sheet of paper, but I was kind of going through and looking at stuff I didn't hit that I know you'll need to know, either for ACT or MCA or real life. And I did find one that was not included in all those notes. And in order to do it, it requires a little bit of an area recap. So just a little reminder of how we get the area of some of our most basic figures. Remember, for a rectangle, area is length times width, and I'm sure you can remember that. And so for a square, they're the same, so it'd be side times side or side squared, but length times width will do it for that. Remember, for a circle with radius r, our area is pi r squared. These are two of our more common ones. Remember, for a triangle, our area is 1/2 base times height, and I'm going to let you catch up. And I'm just doing our most common area formulas because then we're going to just do a little bit of what's called geometric probability, which is going to require you to retain these. So next up, remember our trapezoid that has two parallel legs, and we've got a height in here, and those legs we call the bases. Now base 1 and base 2. Let's neaten that up a little bit. Base 1 up here at the top, and base 2 down here at the bottom. And remember that our area is equal to 1/2 of the height times the sum of the bases, just in case you forgot that one. For our regular polygons, remember it's all about the triangle. Remember, n is equal to the number of sides. And so we're really finding the area of one of these triangles, and then we're multiplying it by n. So the area of one of those triangles is found by doing 1/2 the base, and this is a side length, so they'll give you one of these sides, so it becomes 1/2 the base of the triangle, but if you like to use the side length, that's fine, times the height of the triangle, which they actually call that the apothem, but this is really just 1/2 base times height, and if you prefer to write that, go ahead. That gives you the one triangle, and then you need to multiply that by n because you have n of them. So for this one, for example, because sometimes this one deserves a little extra attention, had the side length been 4, had I pointed at that height and said it was 5, the area of that entire figure would be 6, because I have 6 triangles. Each one is 1/2 of the base times the height, and that's the easiest way to do that. The other ones that you might have, I think on the worksheet, I'm going to keep it pretty much, I think I kept it pretty much just triangles, circles, squares, the trapezoid or something. So good enough. When you're doing geometric probability, and this I called 7.1, so go ahead and label this geometric probability, and I'm just going to give you just a little bit of exposure to this because this is something that they love to test you on standardized tests. So let's go take a look. If we do any kind of probability, like if I were to say, what's the probability that in a bucket full of, let's just go ahead and write 4 red, and you don't need to write this on the side, and 5 blue marbles. If I were to say, what's the probability you pick a red? For probability, you always put the total on the bottom, so there are 9 marbles, and I want to know what's probability I get on the top, pick a red, so that would go on the top. What you always do for probability, regardless whether it's geometric or numerical, is you put the total on the bottom. But when we're doing geometric probability, this would be total area of the entire, it's like you're kind of shooting at a target, and we want to know what's the probability, suppose it was actually like a bullseye like this, what's the probability that if you hit the target you get a bullseye? Well, the total area would be the area of my entire target, because I said what's the probability if you hit the target you get a bullseye. And on the top is the area of where I want to land. So I'm going to put area of what you want. So if you can find areas, you can do geometric probability. I'm just going to put two of them up here. If it's obvious, for example, if I take a regular pentagon, which is chopped into 5 triangles, and I say, what's the probability if you shoot at this, you get in this one or this one? Well, this doesn't require any math because I can consider the whole thing or my total 5 triangles. And what I want is to land in 2 of those. So I don't even have to do the area. It's not necessary because I can see that that's 2/5, so I would just be done. So if it's as easy as that, great. But if maybe they take and give you a square. So let's draw this one. And maybe that square is 8 by 8. And inside I stick a circle that's perfectly tangent to all the sides of the square. Not the best drawing ever. I'll put a little right angle box in these so that you know that this is a square, not just a rhombus. And if I say, hey, what's the probability you land in? If you shoot at random, what's the probability that a randomly selected point, let's call that a dart, lands, assuming it hits the target, in this shaded region? Well, on the bottom, taking a while to shade this stuff, aren't I? On the bottom of my fraction is the area of the entire target, and it's a square, and a square's area is 8 times 8. So on the bottom of my fraction is 8 times 8. On the top of the fraction is the area of the stuff I want to land in. Well, I don't know how to find the area of that shape, let alone multiply by 4 to get all of the blue stuff, but I do know how to get the area of the circle. So if I could find the area of this circle with a radius of 4, so it's half of that 8 there, and then take the square, which is 8 by 8 or 64, and subtract off the area of the circle, then that would give me, again, what I'm doing is I'm doing the area of the whole square, 8 times 8, minus the area of this circle, pi r squared. It's kind of like you're cutting this entire green stuff out with the subtraction sign, and what's left would be the blue stuff. So it kind of makes sense. And so then I would just go to my calculator and do the top part and then divide it by 64. So let's go do that. It would be 64 minus pi times 4 squared. So I'm just doing the top, and I'm going to write it as a decimal. It's round to the 10th. So let's say I got 13.7 when I did this top part. When I divide that by 64, I get 0.21. And so I'd say I have about a 21% chance of a randomly thrown dart that hits the target landing in the blue stuff. So maybe one more, and we'll call that good. One more of these. Let's suppose there's one like this, I think, on your sheet. So suppose I had a rectangle that's 8 by 5, and I throw 2 circles into it, and my circles look like this. Oops. Let's suppose they touch here. So I'm going to throw a couple circles in here. I'm going to go kind of to the center, make that. I'm going to do a circle like that, and then a circle like this. Not the best drawing, but if this is 8 all the way across and these hit in the center, which I'm telling you, then this is 4, which means the radius of this circle right here would have to be 2. And then suppose I want to find the probability that a randomly selected point lies outside of that in this blue stuff, which I don't want to shade in. Well, again, what's the area of the entire thing that I'm shooting at? It's a rectangle. It's 8 by 5. It's got an area of 40. How about the stuff between the rectangle, which is 40, and the circles? Well, I'm going to take the rectangle and remove those two circles. I've got two circles, each with a radius of pi times r squared. So I'm going to repeat what I just did there. I did my total, which would give me the area of this rectangle, and I put it on the bottom. I then wanted to get in between, so I'm going to cut these circles out of the area of the entire thing, which was 40. I'm going to cut out two circles with a radius pi r squared. And then I just go to my calculator and calculate that, which I'm confident you can do. So the last thing you need to do is worksheet 7.1, and then there's no test. You can be done. Have a good one.